Hi, my name is Syamil Farah Amani binti Samruzaman.
Hi, my name is Clothesline binti Syamsul Bukhari.
Hi, my name is Nuri Shahira binti Zulfitri.
I'll be explaining the introduction of this project. Modern living requires efficiency and convenience, particularly when it comes to handling regular home chores. Drying clothes is a typical problem for many households, and it is frequently impacted by unpredictable weather conditions like unexpected downpours or extreme heat. In order to solve this problem, this project presents an automatic clothesline system that uses automation technology to offer a more intelligent and dependable way to dry clothes. This project aims to design a compact, practical, and user-friendly automatic clothesline for daily home use. It also saves time and effort, especially for users with busy schedules. The system is easy to install and suitable for different residential environments. The objective of this project is to design a compact and practical automatic clothesline system for home use, to improve the clothesline drying process using automation and sensor technology, to test the system to ensure it works properly and benefit users.
Now, let's move to digital collaboration. There are 4 apps that we had used to make this project successful. Number 1, WhatsApp. WhatsApp is our main communication platform throughout this project. We use it to discuss ideas, divide tasks among team members, share progress updates, and solve problems together. This helps ensure that everyone stays informed and involved in important discussions and decisions. Number 2, YouTube. YouTube is an important learning resource for our project. It provides step-by-step tutorials and demonstrations on rain sensors, Arduino connections, and system integration. By watching these videos, we can better understand how the system works and apply it correctly during development. Number 3, TikTok. It is used as an additional platform for learning and inspiration. Short educational videos help us discover project ideas, understand how similar systems are built, and learn practical tips in a simple and engaging way. It also helps us explore creative features and real-life applications. And lastly, Arduino IDE. Arduino IDE is the main software used to program and control our smart rain detector system. We use it to write, edit, upload, and debug code on the Arduino board. Through testing and debugging, we can improve system accuracy and ensure the project works as intended.
Now, let's move to approaches and techniques. First, connection between raindrop sensor and microcontroller. The raindrop sensor is used to detect the presence of rain or water. It is connected to the Arduino Uno using jumper wires. When water touches the sensor surface, a digital signal is sent to the Arduino for further processing. Next, rain condition detection. The system continuously monitors the rain condition. The Arduino reads the digital signal from the raindrop sensor. When rain is detected, the sensor sends a low signal to indicate that it is raining. Next is servo motor control for cloth rack movement. The servo motor is used to control the movement of the cloth rack. It is connected to the Arduino through a PWM pin. The Arduino sends control signals to rotate the servo motor to a specific angle. And last is automatic movement of cloth rack. When rain is detected, the Arduino commands the servo motor to rotate and pull the cloth rack inward under the roof to protect the clothes. When no rain is detected, the servo motor returns the cloth rack to its original position. Our project consists of 3 members: Krotu Ain as the project manager, Syamil Farah Amani as the software designer, and Nurin Shahira as the software engineer. As a project manager, they need to prepare a clear project plan that includes the project scope, objective, tasks to be complete, and the timeline for each stage. Second, they need to distribute tasks to group members based on their skills and strengths, while making sure everyone communicates well and understands their role. Third, manage the project budget and ensure that all expenses stay within the approved limit. Fourth, monitor the progress of the project regularly to make sure milestones and deadlines are achieved without affecting the quality of the work. And 5, ensure that all project deliverables meet the required standards and align with the project objective.
Now, let's look at the software engineer's responsibilities. My role in this project focuses on software development. Software engineer's responsibilities includes design and develop software applications based on project and user requirements, while ensuring the code is clean, efficient, and well documented. Aside from that, they also have to work closely with team members to understand system needs and translate project objectives into functional software solutions. In addition, they have to program, test, and debug Arduino-based software to make sure the system operates correctly and responds accurately to sensor inputs. Lastly, they help develop system flow and documentation, and continuously test and improve the system to ensure stable and reliable performance.
As a software designer, my responsibilities is to design the physical structure and mock-up of the automatic clothesline system using suitable materials. Select materials that are durable, safe, and cost-effective for the prototype. Test the prototype to ensure it is safe, stable, and functions properly. Solve design issues to improve system performance and ease of assembly. Work with team members to ensure the design supports the electronic components and overall project goals. Now, I'll be explaining about the timeline and activities. On 5th of 11, we choose and discuss a suitable automatic clothesline system that is practical and feasible for the project. On 6th of 11, we explain the project objectives, requirements, and scope of the automatic clothesline system. We focus on an automatic clothesline that reacts to environmental conditions to improve household convenience. We also identify and research suitable electronic components such as sensors, motors, microcontrollers, and supporting modules. On 10 of 11, we compare selected components using an online platform to ensure they meet project requirements. On 18 of 11, we purchase all selected components and wait for the ordered components to be delivered. On 25 of 11, we receive the components according to the delivery schedule. Next, on the 2nd of December, we check that all components are complete and in good conditions. On the 6th of December, we test the quality and functionality of the components before use. On 13th of December, we buy additional mock-ups materials such as artificial grass, cardboard, clay, and cotton. On 17th of December, we design the hardware circuit and develop the software code at the same time. Then we integrate hardware and software to ensure the system works properly. On 3rd of January, we build the mock-up and assemble all components carefully. On 7th of January, we test the system using water to simulate rain conditions. Lastly, on 14th of January, we present the completed automatic clothesline system prototype to the lecturer and classmates.
Next, let's look at the components of this project. There are 5 components. Raindrop sensor. The raindrop sensor is used to detect the presence of rain by sensing water droplets on its surface. When rain falls on the sensor plate, the resistance changes and a signal is sent to the microcontroller. This allows the system to automatically detect rainfall and trigger the cloth rack to move indoors, preventing the clothes from getting wet. Arduino Uno R3 SMD. The Arduino Uno R3 SMD is the main controller in this project and acts as the brain of the system. It processes input data from the raindrop sensor and controls output components such as servo motor and LED. It is chosen because it is easy to program, reliable, and compatible with many sensors and modules. Jumper wire cable female-male type. Jumper wire cables are used to connect all electronic components to the Arduino Uno. The female-male jumper wires allow secure connections between the sensors, LED, servo motor, and microcontroller without soldering. They also ensure stable signal transmission and provide flexibility during circuit assembly and testing.
The ST90 servo motor is used to control the movement of the cloth rack. It receives signals from the Arduino and moves the rack inside when rain is detected. Its lightweight design, precise angle control, and low power consumption make it suitable for this small-scale automation project. The power bank serves as the main power supply for the system. It provides stable power to the Arduino and other components, allowing the project to operate independently without a direct power source. This makes the system practical for outdoor use.
For the coding part, we use the Arduino IDE to program the smart clothesline system. The code allows the Arduino Uno to read input from the raindrop sensor and determine whether rain is detected or not. When the sensor detects rain, the Arduino processes the signal and sends an output to the servo motor to move the clothesline indoors. At the same time, the LED is activated to indicate that rain has been detected. If no rain is detected, the system remains in its normal position. The code is also tested and debugged in the Arduino IDE to ensure accurate sensor readings, smooth motor movement, and reliable system performance. This is the result after everything is put together. Our clothesline system works perfectly. This project focuses on developing a smart rain detector to protect clothes from getting wet. The system is designed to reduce the need for constant weather monitoring by automatically responding when rain is detected. A raindrop sensor is used to detect water droplets and send signals to the Arduino Uno R3 SMD, which acts as the control center of the system. Based on the sensor input, the Arduino decides the appropriate action. When rain is detected, the SG90 servo motor is activated to move the cloth rack indoors, protecting the clothes. Jumper wires are used to connect the components without soldering, making the system easy to assemble and adjust. A power bank is used as the power source, allowing the system to operate independently. Overall, this project demonstrates how simple automation can solve everyday problems by saving time and improving user convenience, with potential for future improvements.
In conclusion, the automatic clothesline system successfully demonstrates how simple digital electronics and automation can be applied to solve everyday household problems. By combining a raindrop sensor, Arduino Uno R3 SMD, and a servo motor, the system is able to automatically detect rain and move the cloth rack to a safe position, preventing clothes from getting wet. The project achieved its objective by designing a compact and practical system that operates efficiently with minimal user intervention. The use of affordable and easily available components makes the system suitable for real-life domestic applications. Throughout the development process, testing confirmed that the sensor detection, signal processing, and motor movement function as intended. Overall, this project highlights the importance of automation in improving convenience and saving time in daily life. With further enhancements such as additional sensors, improved mechanical design, or mobile notifications, the automatic clotheslines system has strong potential to be developed into a more advanced smart home solution.